Chapter 5, Section 3 begins with polyatomic ions. This is part 1. A polyatomic ion is simply a group of atoms that have already been covalently bonded together that has a charge to them. So they behave as if they were a single ion. So the couple examples I have here, this is the nitrite ion, NO2. So the nitrogen is already bonded to these two oxygens, and this whole structure has a -1 charge. So it behaves just like it were one of the halogens that all have a -1 charge. This one here, sulfate, SS with 2 oxygens attached to that sulfur. And together they all have a -2 charge. So they would behave just like they were part of the oxygen family. That whole group has a -2 charge to them. And that is the sulfate ion. Most of the polyatomic ions are going to be oxyanions. Anions, you know, means that they are a negative ion, and oxygen just means that they're going to have oxygen in them. Now you're going to see two endings very commonly, the ate or ATE ending and the ite or ITE ending. The one with the ate ending is going to be the most common of the two ions. So sulfate is SO4 with a 2- charge. Sulfite is going to be the ion with one less oxygen than the most common one. So this one would be SO3 with a 2- charge. Nitrate is NO3 with a 1- charge. The nitrite ion then would be NO2 with a 1- charge. So the ite ending always has one less oxygen than the ate ending. Now sometimes you need more than 2 options for an ion. Hypochlorite, for instance, is the active ingredient in bleach, and there are actually 4 different versions of this ion. You have your chlorate ion, which is ClO3 with a 1- charge. Chlorite then would be ClO2 with a 1- charge. Now there's actually a ClO with a minus charge, and that one we would call hypochlorite. We add that prefix before the chlorite. And then with one more oxygen than the chlorate, that becomes perchlorate, which is ClO4 with a minus charge. So we go hypochlorite, chlorite, chlorate, and then perchlorate. And each one of those we add one more oxygen. Now for naming compounds that have polyatomic ions in them, it's similar to binary ionic compounds, and it's actually a little bit easier even. The cation always comes first, so we're going to state the cation. So here our formula is K2CO3, so K is potassium, and then CO3 with a 2- charge is carbonate. So we simply state the cation, state the anion, potassium carbonate. There's no changing the ending to IDE. It's just state the cation, state the anion. Here are a couple more examples. NaOH. Na is sodium. OH 1- is hydroxide. So our formula is sodium hydroxide. LiClO2, well, Li is lithium, and then this is chlorite. H2O2, now this one's a little bit tricky. O2 with a 2- charge is the peroxide polyatomic ion, and H of course is hydrogen, so hydrogen peroxide. Then this last one here we have Ca, that's calcium, and CO3 with a 2- charge would be carbonate. Now you'll also have to be able to write the formula from the name. So in this one here we have calcium chloride. So calcium we would look up on our periodic table. We would see that its symbol is Ca and it's in group 2, so it's going to have a 2+ charge. And then chlorite on our polyatomic ion sheet is ClO2 and it has a 1- charge. Now we need to make sure that we balance the positives with the negatives. So calcium's a 2+ and chloride is a 1-. So we need 2 of those chlorite ions in order to balance out the calcium. So we would write the chlorite ion in parentheses and put the 2 subscript after it. And what those parentheses does then is make sure that we know that this 2 goes to both the chlorine ion and the oxygen. And if we only left it at the end, then it would only refer to the oxygens and not the chlorines. So we need to say that we have 2 of this entire structure, not just one or the other. So we cross that 2 down from the calcium and the 1 down from the chlorite, and that gives us our formula here. Here are a few more examples. We have iron 2, which means iron is a 2 plus, and hydroxide, which is a 1 minus. So we have Fe, and we're going to cross that 2 down, put our OH in parentheses, and bring that 1 down. So we have Fe, an OH in parentheses with a 2 subscript. For this one here, we have potassium, which is K, and it's a +1, and dichromate. The dichromate ion is Cr2O7, and it has a 2 minus charge, so we're going to bring that 2 minus down to balance the potassium's 1 plus. Aluminum is a 3 plus, phosphate is a 3 minus, so it's already balanced, so we just write AlPO4. And then our last one here is ammonium nitrate. Now ammonium is a polyatomic ion. It's one of the few positive polyatomic ions that there are. So it's NH4 with a 1 plus charge, and nitrate is NO3 with a 1 minus charge. So again, that positive is already balanced with the negative, and you get NH4, NO3.